So starting chapter 9, our geometry magic, 271, 272 of the workbook here. And to get this started here, terms galore. So, when we're dealing with geometry, there's a number of specific ways things are represented and written. Just looking at the homework here, you see these arrows up here, you see these two lines over here, you see another type of line over here, a line with just one arrow on it. There's a variety of these different types of symbols going on here. So we're going to talk about terms, we're going to define the terms. When appropriate, I will provide the geometric or mathematical symbol that corresponds with various terms. So when you see these throughout this chapter, you understand what these symbols represent, how to interpret them, how to write them, all this stuff you have to do here. So to begin with here, we have our friend, the point. All right. So a point is an exact location in space. All right. Points are represented by dots and named by a letter, a point. And again, points you'll see all over the place here. Just throw one out here, but there's a point, and I give it a name. We'll call this A. How's that? So, looking here at my work, we see all points all over the place here. These are all points. There's point C on this line, point D, point E, point F. There's point M inside this plane here. There's point A. Some more points over here, point X, A, C, B, all over the place. So points, again, pretty to understand. They can be part of a line, they can be inside angles, they can be inside planes, spaces, they can be anywhere. More points back here. All those are points. Notice how, again, they just look like a dot. They have a letter next to them. That letter represents specifically what point we're talking about. If I say find the point in here, you'll say, well, which one? There's a ton of them. Well, if I say find point F, well, then you go, oh, there's point F right there. So we always represent them with a letter. Okay? So all it does is represent a space somewhere or another. Cool? Great. A line. All right. So a line is a continuous set of points in a straight path. Okay. Lines are named by any 2 points on the line. So, continuous set of points in a straight path. So I'm going to draw out what would be a line here, and there's a couple things we need to represent here. Okay. So this is a line. Now, geometrically, a line is defined as never ending in both directions. That's what these arrows mean, that in fact the line keeps on going and going and going here. There is no end to this line here. And I could call this, again, I could throw some points on my line here. Just put A, B, C. So this line has a couple different names that it could be. We could call it line AB, we could call it line AC, we could call it line BC. These are all acceptable definitions for the line. Lines have geometric symbols. So the geometric symbol for a line, typically when you represent a line, it's most common to represent the point that's farthest on each side. So this right here is my symbol for a line, right here. And I could call this line AB, or I could call it, probably the best name would be AC, or I could write BC. They're all technically correct, but this right here is the clearest definition, I would say, just because it takes the points that are on both ends. So the key thing when we're talking a line is lines must have these arrows on both sides. We're going to be looking at some different representations here very soon. And you'll see the difference between lines, line segments, and rays. Those are all different things here, but they all kind of look the same to an extent. But a line is never ending in both directions. All right? Just because I stopped it here doesn't mean the line ends. It does keep going, but again, due to lengths of paper and just reasonableness, you just cut it off at a point there. Okay? So there's a line. So let's talk about collinear. What does that term mean? All right. So collinear and non-collinear pertain to lines. They pertain to lines. All right. So collinear. If a straight line can be drawn through a set of points, the points are collinear. So I can go back to where we talked about here. I'm just going to go back up to this line right here because it's just fine and well. But these points are considered collinear because I can draw a straight line through all three of these points, right? I just drew a straight line again. Don't have a ruler. If I had a ruler, it would be more precise, but pretend it's a perfectly straight line. And all these points here are collinear because they can all be drawn through a straight line. I can connect those 3 points together with a line. That makes them collinear. That makes them collinear. Non-collinear. If no one line can be drawn through all the points, the points are non-collinear. So how would this look here? Non-collinear points. So if I had A, B, and C, this would be an example of non-collinear points. Because again, I could draw a line to connect two of the three. I could connect C to B, I could connect A to B, and I could connect A to C, but there is no one line I could draw that would connect all three, no straight line that's going to connect all three of those points. Again, I could use two lines, but the whole key is it has to be one line. And if I can't draw one line through all the points, then the points are considered non-collinear. Now, if I drew just one line, and eliminated one, I could just draw a line through A and B. Now, they would be collinear points. And I could draw a line through AC, and AC would be collinear points. But there's simply no way A, B, and C can be collinear points, because I can't draw one line through all 3 points. Okay? Agree with that? Collinear, non-collinear. All right. Anybody have a favorite term so far?
I hate them all.
Well, if you haven't found your favorite term yet, good news. There's lots more coming. So lots more coming. Okay. So at this point here, we've talked about a point, we've talked about a line, we've represented a geometric symbol for how lines could be represented here. We talked about differences between collinear points, non-collinear points, the difference between them, one line only. Okay. All right. Now we're moving on here. Everybody good with this page? Anybody need anything else before I start a new page? Going once, going twice. Okay. Let's continue on. Boy, this is magical, isn't it? A line segment. All right. A line segment is a part of a line. And this is the whole key to it, has 2 endpoints. Okay. It's a part of a line. So look like this. This is a line segment. And it also has a geometric representation where this would be line segment DE. So to represent a line segment is you just draw line segment, such as that. And I'm just going to contrast it for a second to what we did with the line here. So with the line, again, this is not the end of the line here. This is not where the line ends. This is just 2 points or 3 points that lie on a line. But notice how the line continues beyond those 2 points there and continues on to infinity. So we still need to be able to classify the line, call it something. So that's why we need 2 points. We're 2 points on the line. And it's represented by the symbol, which again represents it as a line. It goes on to infinity. But there could be plenty of lines. I could draw a line here, throw on more points, and I could draw another one up here, and on they could go here. So we need to be able to differentiate between lines. There's frequently more than one line or segments inside of a representation here. So this is why we need to use points here. If I'm talking about this line this line or this line, I need to be able to identify it somehow. So I know which line that we're talking about. But all of these go in endless directions. But the line segment terminates. It does not endlessly go on. This is where it starts, this is where it ends, or vice versa. This is where it starts, this is where it ends. It does not go beyond those points. It is a segment. All right? If I draw, say, a triangle, for example. All right, there's my triangle. Make it a little official, get that. But a triangle is composed of basically 3 line segments. Not lines, but line segments. Those are line segments. Segment AB, segment BC, and segment AC are the 3 line segments that make that triangle. It terminates. It doesn't go on endlessly in all directions. All right? Line segments. So, big difference between a line and a line segment. Okay? You agree with that? Right. Okay. So, geometric representation looks like this. Just the line, just like the segment there. No arrows. The line has arrows on both sides of it. That makes it a line. This makes it a line segment. No arrows. Different representation. Okay, array. All right. Array is a part of a line that has one endpoint. And continues infinitely in the opposite direction. And naming it is specific. So to name, use its endpoint first, followed by any other point on the array. So the array is kind of in between what the line segment and the line is. The line goes on infinity in both directions. All right? The line goes on through infinity both directions. The line segment terminates in both directions. So I think, again, think about the sun is a good way to do it. You got the sun up there, right? And then the rays come off the sun. The sun is just there, doesn't really move, right? But then there's all the sun rays that shoot off into all directions from the sun. So how would this look here? Well, we start with an endpoint. We'll call this G and H. So this would be a ray. It has one endpoint. So here's my endpoint right here. And continues infinitely in the opposite direction. Right there. That is being represented as going through point H and forever and ever it shall go. But it starts or originates at point G. That's where it begins. Right? So to represent this here, our geometric symbol is, once again, this time it's kind of like the line segment, kind of like the line, but just one arrow. And you always set it up this way because to name it, you start with the endpoint first, which is G, and then I could pick any point. This one only has one other point, so I would call this ray GH. Okay. These are the three types of lines that we use in geometry. All of them are either lines, rays, or line segments. Everything is one of those three things. Either it goes on to infinity in both directions, terminates in both directions, or one of the two directions goes on to infinity. And just like if I wrote it this way, again, simply, I could call this, we'll call this I, J. How would I represent this here? What would be my geometric representation of this? JI, right. So again, it's a little backwards, but to properly represent it here, you always use your endpoint first, and then your point through infinity is second. That matters greatly. So you never ever represent it with this symbol. This is not a symbol, okay? This right here, not a symbol. The arrow is always pointing to the right. And it's up to you then, even if it's backwards or flipped around, that you still represent the endpoint first, followed by the point through forever second. Okay? All right, so there's the ray. So now we've talked about lines, line segments, we've talked about rays, we looked at points, we analyzed the difference between collinear points and non-collinear points. So we're building up our database here a little bit. We've learned a bunch of different symbols so far, line segments, lines, rays, points, how do they all look? We're learning. We're getting some good stuff down here. Fortunately, we got plenty more still to go, so we're not done yet. I don't think we're done. Oh no. Huh? We got a ways to go. Okay, an angle. And again, I would assume we know what an angle looks like. That's great. But an angle is a figure formed by two rays with a common endpoint. And we're going to just tie in another definition right now. So I'm just going to go down here. A common endpoint is called the vertex. And there can be more than one, so sometimes you'll see the plural version of it called vertices. And depending how many line segments and rays and all that that's going on here, there can be more than one vertex inside of an angle. All right. So the rays, there's a lot to say about angles here, so get ready. All right. The rays form the sides of the angle. Naming angles. I'll show you what this all looks like here in a second here. So, a couple different ways you can do this. You can use And this is the most common way. The letters of 3 points that make the angle. The vertex is always the middle letter. Sometimes angles will be represented by numbers, which is not something we really see in this lesson here, so we can just deal with that at a later point here. But I'm going to draw one out here. So I'll just call this J, K, L. And there is a geometric representation for what an angle is. So this meets our definition of an angle. And again, this will get expanded on quite a bit in the next couple chapters. But for today, this is where we're starting here. Once we start working with polygons, which are rectangles, triangles, pentagons, stuff like that, we understand that there are interior angles inside of them, which is a classification of a type of angle. But what is common is this is my angle right here. So these two rays do share a common endpoint right here, right? Ray KJ and ray KL, two rays share the same endpoint right there, point K. That's the common endpoint between these two rays. And this right here, point K, is considered the vertex. It is the common endpoint. So if I say, what's the vertex of this angle, you would say K. K is the vertex. Now, naming this angle, it doesn't matter which way you go about saying it here. Now, this matters more later on because there's actually two different angles in here. You can clearly see this angle right here, right? This angle. But there's actually another angle in here too. Did you know that? There's two angles here. Anybody know where the other angle is? Right. This is also an angle. So there's two angles here. There are two angles. So there's two different ways I can represent this angle here. And for now, we'll just focus on the small one here. We don't need to get too bent out of shape about this right now, but we'll get there before it's all said and done. I promise. We'll get there. So the symbol for an angle is basically this. Think the less than symbol, more or less. That represents an angle. And an angle is represented by three letters, always. Because there's always 3 points. Whether I even go back to my triangle, again, not technically raised, but again, depending which angle I'm talking about, if I'm talking about this angle, or this angle, there's different ways they would all be represented. So when you're representing an angle, you basically go in order here. You take an endpoint, we'll go with this one, then we have the vertex, and then we have our other endpoint. So this could be angle JKL, which is fair. Could also be called, what's the other angle, or how could I represent this angle? What's the other way I could write it? LKJ. Right. Both are fine. Both are acceptable. Doesn't matter the order that you're represented. But what does matter is that the vertex is in the middle. And that is absolutely vital to everything here. because again, it's pretty easy to see right here, right? But if I go back to my triangle and I say, well, what's this angle right here? You don't have to write it out, but how would I represent this angle right here? This one, right here. How could I say it? Angle BAC or CAB, right? But if I said, well, represent this angle over here now, this angle this time, how would I represent that? I could do BCA or ACB. But it matters greatly because if I just write BAC with no context and don't know what we're talking about here, is that this one, or this one? I wouldn't know. But now that I know that the vertex is always in the middle, I know that we're talking this one. When I see that C in the middle, I know that we're talking about that angle. So that's why it really is critical that your vertex is always in the middle in your representations here, to make sure that you're identifying the proper angle that you're talking about. You'll see things like this. You know, this could be C, and I got A, B, D, and E. And again, they all have that vertex of C, but it's all about which angle am I looking at. Am I looking at BCE? Am I looking at ACD? Am I looking at DCE? There's a lot of angles in there, isn't there? I could be looking at this whole angle. That's angle ACE, that whole thing. Or this angle, or this angle. They're all different angles there. So how you represent this information matters greatly, because frequently there'll be a lot of angles going on, so you need to be very specific about how you represent your information here, so we can find the angle that we're talking about. And ditto, if I would say find the measurement of angle BCE, you need to be able to understand what am I talking about here? What am I trying to solve for? Huh? You will see this symbol a lot, all over the place here. Not so much in here, it looks like, but you will see it a ton. In these next two chapters, this symbol right here, the angle symbol. So you need to understand what it is, and you need to understand, if I put this all out here, what are we talking about? Okay. Okay, here we go. Plane. Plane. All right, so planes are flat, two-dimensional surfaces that extend infinitely in all directions. Right. It is named by at least, you can certainly have more, at least 3 points in the plane that are not all collinear or non-collinear points. Last thing, points and lines that lie in the same plane are called dun, 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 coplanar. And we're not going to get real deep into planes here. It's a pretty vast, dealing with multiple dimensions and stuff. It's a little bit beyond what we need to do here. For our representations here, usually it'll show up in some sort of geometric shape like this, which has no official boundaries, but I can't just nothing, and just be like, goes on to infinity. So again, imagine this there's no measurements to these lines here. They just think the universe or whatever, just there it is. So I could have A, B, C, D. So there's my four points there. So to name this plane here, and again, there is no geometric symbol for plane. When it comes up, you usually just write the word plane out, such as this. There would only be one really wrong answer here. What would be my wrong answer? Anybody know? What would be the wrong answer? ABC. Why is ABC wrong? Right, those are collinear points. Those are collinear. So I need at least 3 points, right? But they can't be collinear. So ABC would not be an acceptable. I could call it ABCD. That's okay. I could call it ABD. I could call it DCB. Somewhere in there you need to have D in your answer. If you don't have D in your answer, it's probably wrong. It is wrong. Because ABC forms a collinear line. So that's not what you want. No good. No bueno. Bad stuff. So there's my plane there. Again, we're not going to focus on them too much. All you need to understand here is that this has no beginning and end here. And there could be an infinite number of points inside of there. Really, this is as far as we're going to go with planes. You'll see them in this lesson. You need to be able to identify, define them, and that is as far as we need to go with planes. Okay? So don't get too bent out of shape about planes. Okay, continuing on. Yes, we are not done. No, we are not. Okay. Intersecting lines. And for our purposes here, we're going to go with 2 lines. Got to have 2 lines that cross at exactly 1 point. This one should be pretty easy to understand. So I can these are intersecting lines. Again, I can give them all titles here if I so choose. We'll go with V, W, X, Y, Z. So these lines are intersecting. They are 2 lines that intersect at exactly 1 point. Point Z is where they intersect, right here. That's the point of intersection between these 2 lines. Really all there is to it. Probably one of the easier terms to understand, because I think you know what it is. So intersecting lines will always form an X of some sort. Doesn't matter how narrow it is or anything. I mean, again, I can draw them forever here, but as long as they connect at some point, they are intersecting lines. Okay? Two more terms, and then we are done.
Mr. M,
Yes, sir.
this is your homework, right? 7th graders?
Yes.
Okay, so kids, what we need to do at Mr. Meltzer, if you could, some point today with these kids, we need to move all your stuff because of the leaks that we've had going in there. there's stuff coming on the floor. I think we have the leak fixed, but I don't want your stuff getting soaked. So this hallway, where there's a bunch of random coats and stuff, we
Okay.
need to just take all those off there and throw them up on the shelf or something for now. I'll deal with that next week. But you kids are gonna now start putting all your bags and everything on the hooks in the hallway here, okay?
Okay.
So that we don't I want them getting soaked or wet or anything over there, okay? Right, I appreciate that.
Yes, sir. Thank you.
Have a good rest of the day, everybody.
Thank you. Okay. Perpendicular lines. Two more terms. So perpendicular lines. Intersect to form a right angle. Must form a right angle. Has to form a right angle. If they don't form a right angle, they aren't perpendicular. So, again, we'll draw this out here a little bit, and there's a couple different symbols we're going to glean from here. There's also a representation. Let's go with M and O, sorry, P. So, couple different things that we need to see here. So, first off, form a right angle. Right angles have a specific symbol. Does anybody know what the right angle symbol is? It's this box right here, like this. Basically forms a square. But this is the symbol for a right angle. And you will absolutely see this plenty. If I look in here, we can see there's one right there, there's one right there. On and on. Looks like those are the only two in this assignment, but this, by definition, tells me this is a right angle, 90 degrees. Right angles are 90 degrees. So just looking at this here, we can see that there are indeed some perpendicular lines formed here. Basically, this line AX is perpendicular to line AB. Agreed? Because there's my 2 points on the lines. Line AB is this line, line AX is that line. So lines AB and AX are perpendicular lines. So to represent it here, it also has a symbol. If I wanted to represent this as perpendicular lines, I could say that line NP, and this is my symbol for perpendicular. It's basically an upside down T. It's perpendicular to line MO. Right there. That's the symbol for perpendicular. And again, you will see this symbol throughout the chapter here. Frequently, the information will be presented to you with symbols. In this chapter, it's not going to be words. It's not going to say find the perpendicular, blah, blah, blah. Sometimes it will, but a lot of times it would just have this symbol, meaning perpendicular lines. So this is how you would represent this information, saying line NP is perpendicular to line MO. All right? Must form a right angle. Last term. Parallel lines. Okay. Parallel lines never intersect. That's really all there is to it. So, again, if I had a ruler, I'm sure I could make it as precise as possible, but we'll just say for all purposes here, we'll call this A, B, and then we got one thing we gotta work on. I know we're going a little long, I apologize, but it is what it is today. So, for all practical purposes, pretend these are as straight as can be, straight as a bell, straight as a whistle. They would never, ever, ever intersect. And that, by definition, makes them parallel. They would never intersect. No matter how long I drew this line to infinity, they'd still never intersect. All right? So, symbol for it. So, line AB, and this is the symbol. It's basically two lines up and down. Right there is my symbol for parallel lines. This two lines right next to each other. That means parallel lines. Line AB is parallel to line CD. Okay? Last thing we got to do, then we're out of here. Okay? We're done with definitions. Congratulations. So I got one small exercise here. I'm going to just draw it out real quick.
Is this going in our notes?
I probably would, but, it's up to you here. Okay, so I'm going to draw this, and then I'm going to go like that, go like that, and I'm going to call this R, S, Q, T, U, throw a right angle in there. So, now I'm going to ask you some questions here. Again, I'm not directing these at anybody in particular here. This will only take 2 minutes, so just bear with me. So, tell me the 5 points that are inside here. What are my 5 points? Anybody want to tell me the 5 points?
Q,
Q, S, U,
and R.
no E,
T.
T,
R.
R. Those are the 5 points. Good. What are the 4 rays? There's 4 rays in there. US, UR, UT, UQ. And of course, all of those would be represented using my ray symbol. And again, the order matters. You always list the endpoint first. So there they all are. Those are the 4 rays that are in there. There are 8 line segments. What are the 8 line segments? And you have ST. Where's the last one? QR. In the order of these doesn't matter. This could be RU, TU, SU. So you may be asking yourself, well, wait a second. Isn't ST a line? Well, sure, it's a line. It is a line too, but when I represent it this way, I'm only talking about this portion right here. It's also a line, no doubt about it. Just like UT is also a ray. But the ray includes this part right here. The line segment ends and starts at this endpoint right here. I'm only representing this. So this is both line segment UT. This right here is ray UT. This is line segment ST. And now that I add in both these, this is line ST. So it can be both. It just depends what portion or what exactly you're referencing or talking about there. There are two perpendicular lines in this puppy here. What are my two perpendicular lines?
QR,
Line QR,
ST.
line ST. Good. Finally, last question. There are 11 angles inside this figure.
TUR,
TUR could be one.
QUT,
QUT,
SUQ,
SUQ,
SUR,
SUR,
RUS,
RUS,
RUT,
RUT. We already got that one.
QUT,
What?
QUT, oh, we are done.
QUT we got?
SEQ,
What?
SUQ, we
SUQ.
already have it.
Got that? What about SQT?
Yeah.
That could be one. What about SQR? Could that be one? What about QTS? What? TQR? And where's the last one here? Is it SUT? Right. Last one, SUT. This is actually a straight angle right here, which we'll learn about. Straight angles have measurements of 180 degrees. So this right here is an angle, just like this. So there they are, the 11 angles.
Are we done?
Huh?
Are we done?
We are done. Thank you for